Hello.
Manish Nath from Hex-Universe. So Hex-Universe is a space education and research-based platform which helps students to pursue their career in the field of space science and technology to work on projects related to space science. Coming back to our today's webinar, this session is organized our ambassadors in collaboration with SS Citizen Science Group. And our topic for today's achievers association of variable job authors, the category of astronomy. And next we have Ms. KHUSHI Arora. She is also a space educator, science communicator, and social worker. We are very glad to have you both with us here today. Before starting the session, I would like to mention our other collaborators for today, and they are Akash Ganga Science Media and Krakski Center. So without wasting any more time, I'd like to request Teja to proceed with today's session. Thank you everyone, and this is all from my side.
Thank you very much. I would just like to share my screen. Um, I hope you can see my screen. Good evening, everyone. This is TEJA Begari. As was mentioned earlier, I am an ambassador and a very store observer for the American Association of Variables.
Yes, the data is
sort of
visible.
Okay, was AAVS, I think so. Okay. So the AAVSO is an astronomy. So the AAVSO was started Edward Pickering. So AAVSO is headquartered and amateur astronomers and help them collaborate on scientific projects and help in science. There are few so provide despite of their professional interest. It doesn't matter whether you're it doesn't matter who you are. Uh, uh, Axel location. It doesn't matter from which to. This is what the AVSO aims. It is to discovery through variables to astronomy. Talking further, in one of the early webinars by Hex-Star was AAVSO is a truly international community. The AAVSO. And very nice news we got recently is that of you you have over 5 million database of variable store of viewers who are very, very stars, uh, the variable stars educators who educate, who are teachers, colleges, schools, universities, and representatives of the AAVS, to complete. So it's very important for us. So let's start with the night sky. You just go out and you. They are normal stars. So variable stars are those kind of stars whose brightness is not changing. So video clearly. So here this is which were born. See a change in its brightness. It's not twinkling. Twinkling is a different one. The photo taken for so knowing the reason, let's get into that. But you see here, this star's brightness constant with no change in its magnitude. But whereas this stars are what we call the variables. Variable star it is. The light curves. The light curves help you to understand which you can plot a number is high in the brightness. It means the star is very uh, faint. It means the star is very bright. So 10, you see a constant star with you know the same magnitude. We do not know why, but there is a change in its magnitude. This is not seen every day. Are different you see a change in its magnitude, and that is what you call it. I'm using uh, that. There. Whenever this blue, whenever the first star and the second star, you completely block the lights of the second star, and you only very small. Radius is equal to that of the uh, the blue star. So those stars are eclipsing bodies. So this is what, and then it's post little change. That is why exoplanet searching for exoplanets is a little too The reason Sun is a variable star is because Sun is going. So in that stars, which shows spontaneous response, such as the eclipsing binaries. For every sunspots, you can be a solar observer. The specified variables, which are because in 1908, a very important theory in astronomy, a very important theory when you're doing stellar physics, which were called the first standard candles. And Cepheid variables were also used by Edwin Hubble to actually know the distance to the Andromeda galaxy. So the Cepheid variables are those stars which basically pulsate, which means they breathe in and breathe out, which is very interesting. So today you observe the star and it is very small, and tomorrow you observe the star, it's really huge. Why does this happen is still unclear, but we have theories. People say it is because of the ionization of helium in the star, and when it's doubly ionized, there is an increase in its temperature, and then it expands, and then again it collects an electron. So this is all a very deep stuff. But when you get into AAVSO, you understand it very clearly. So Cepheid variables are those kind of stars which breathe in and breathe out. So you can also observe Cepheid variables and report them to the AAVSO. And also there are other kind of stars called as the cataclysmic variables. So cataclysmic variables are kind of eclipsing binaries, but here one of the star is a white dwarf, which really sucks in all the material from the red dwarf star, and hence creates a jet. And when there is say the eclipse going on, there is there is a change in its magnitude. So there's many other things you can do. You can work on spectroscopy of stars. So this is the basic example of science you can do at the AAVSO. Now, how can one be a part of this? How can one be? And I forgot to mention that the data you provide to the AAVSO is actually used by professional astronomers. So that itself has a great honor to say, because the data you give is used by professional astronomers. Now, how can you be part of this? So first, every time AAVSO gives out alerts to some specific stars, if say a scientist is doing his research and he needs observation of one particular star, let's say Betelgeuse, and he gives a notice to the AAVSO, and there is an alert given out in the target tool, and observers give more preference to that particular star and observe that and send the report to the AAVSO. You can select your own targets. Now here, the star, these high priority ones are marked in this symbol, which means they have an alert. Some scientists want to observe that. So whenever it's green, it means it has been a very less time observing it, say 1 day ago. When it's red, it's been a long time observing it. When it is black in color, it means that you cannot see that it's to the other side of the sun. So there is a target tool at the AAVSO which helps you to understand which stars are variables, and you can know the constellation of the star. You can see the latest observation, and you can submit your data. So that is the target tool. Tools for observers. There are 4 important tools, I should say. The variable star plotter, which actually gives you the comparison stars magnitude with whose help you actually going to calculate the magnitude of the variable star. WebOps are the places where you submit your observation. There is VSOT, which helps you to give out light curves for variable stars. And also there is the International Variable Star Index for the AAVSO, which helps you give every detail of a variable star, literally every detail. So tools, as I said, default is a tool which gives you the data. So what am I trying to convey here is this is a very introduction of what AAVSO is doing, and you can also be a part of this. So for that, I actually wanted to give you this introduction with this talk now. And educational material. There is a lot of educational material available at the AAVSO. So if you have a CCD, so how can you observe variable stars and submit that to the AAVSO? So we have CCD guide. So you're interested in exoplanets. So we have an exoplanet practical guide. You're interested in solar observing. You have a solar observing guide. So we also have choice courses in astronomy, choice courses which are paid, but there are also free online events, webinars every Saturday, the first Saturday of every month. And now AAVSO believes that science is going to, you know, increase when we share our knowledge. So that is the reason why educational material is made out of really with the help of quantitative results of the observation. Now here is the thing. The Journal of the AAVSO, the Journal of the American Association of Variable Star Observers. So you can submit your research papers, you can submit your variable star research, new instruments, and review papers. So this is very much to professional scientists who are doing their PhD or if they are doing their postdoctoral research. So it is important. So say you have done enough research now, and you did not give that out to people, you did not share that research. So your research is just going to be with you. There's no way science is going to increase then. You just have your observation with you. And after many years, there's someone else who actually gets the discovery you did, and he gets the credit. It's not about credit, but about how fast we are going to increase science, increase the scientific tempo. So it is important for you to submit whatever research you did. It doesn't matter whether it is very precise, but it matters that you made an observation, you made a research, and that is known to the world, and that can be used by professional astronomers, and in a sense, they can increase scientific tempo. That is what every astro enthusiast's main mission, isn't it? So the JAVSO, you can submit your review papers, research papers, and many do that at the JAVSO. Before JAVSO came in, the AAVSO had a lot of research papers, a lot of review papers, but there was no one to see them. There was no one to understand them. We had like a black hole of research papers. But once we came up with the idea of the JAVSO, they started posting journals, research papers, and there were discoveries made. Really, discoveries made. New variable stars came out. Few comparison stars, which were actually variables, came out. So the thing is, show what you have actually done to the world. That is when you will know the real science. The world knows the real science. So that is the JAAVSO. The exoplanet database. As I said earlier, the AAVSO also has an exoplanet database where you can observe exoplanets, which is, as I said earlier, is a bit tough task to do, but when you are interested, it doesn't really matter. So the goal is to observe long-term light curves of a selected number of exoplanet database and to improve the timing variations, the transit timing variations. And this is actually a very new section at the AAVSO compared to that of the variable stars. So you can also be a part of this, the exoplanet database. And there is also another wonderful thing here is the spectroscopic database. So AAVSO spec, AV spec is also a bit younger section, the spectroscopic observing section. You can observe stars and their stellar spectra and report them to the AAVSO. So right now we have around 13 to 15 observers hosting 363 observations, and there were also a few recently published observations from the University of Los Angeles and different other institutions. So the AAVSO variable star spectroscopic database is also something you can work on. Observing sections. So if you are someone who out of this talk thought you can be a part of AAVSO, then you can. I would really suggest you to go to the observing section of the AAVSO to collect much more information about. Say you're interested in eclipsing binaries, so you can go to the eclipsing binary section, eclipsing binary observing section, and you can get manuals and. You can understand the manuals and you can start your own observation. You don't need a fancy telescope to do observation and send that to the AAVSO. What all you need is to you can even have a nice pair of binoculars. That also gives you at least a close magnitude of the observation for that particular day. So you're interested in spectroscopy, you can go to the spectroscopic database, or you're interested in gamma ray outbursts, you can do that as well. So it depends on what you're interested in, and you can do that, and that is what you can actually report to the AAVS. So if you have doubts of how you want to do this, how you want to start, there are building communities, discussions through forums, there are forums at the AAVSO, where you can discuss about observing campaigns, scientific results, specific stars to be observed, instrumentation, and how you can use the softwares. Every doubt you have related to the AAVSO and variable stars, we welcome you to join the forum, and you can be a part of this real scientific research. And there are also free online events. So here is the thing. In 2021, there were a really nice observing, say, webinars going on, the AAVSO 2021 webinars. So every Saturday they're called as Hour to Hours webinars at 2 p.m. Eastern Time. And in 2022 also we have free online events. But there is also something very very jubilant thing for the members. If you are a member of the AAVSO, you need to pay a little amount to be a member of the AAVSO. And if you are a member of the AAVSO, you get access to events which are not public, but those events which are given out by some of the really great scientists who have been expertised in a particular field, such as the one was by Dr. Jill Tarter, who is into astrobiology, one of the pioneers of astrobiology, who worked at the SETI, Search for Extraterrestrial Intelligence. And in April we have one event which is where the guest speaker is Professor Jocelyn Melbourne, whom I guess all of you here know, who is very famous for the discovery of pulsars. So that is what the AAVSO has. And if you actually want to start observing variable stars and you want to be a part of this and leave a legacy with the AAVSO, sorry, you can be a part of the AAVSO and you can start observing variable stars. You can join our discussion forums, and if you still have doubts, you can please feel free to write us at the aavso@aavso.org. Join us and let us explore the universe together, understand the real wonders of the night sky, real wonders of variable stars. And if you have any precise questions, I would also ask you to please mail me if you would want to. That is teja.amb.aavso@gmail.com. I would share that in the chat. So let us have questions in the last. If you have any questions about the AAVSO, we also have another speaker now who is going to talk about some other citizen science projects. I hope you liked it. Yeah.
Well, thank you, Teja, for this wonderful presentation. Next up, I would like to request Khushi to proceed with your session. Thank you, everyone.
Okay, I hope I'm visible because there was a power cut at my area. Okay, so good evening, everyone. I would like to thank everyone, especially the Hex-Star University Citizen Science Project and SA Citizen Science Project, to give me this golden opportunity to present the amazing opportunity and amazing facts about the citizen science. Who are the citizen scientists and what exactly they do? What are the projects in which you can get involved and what will be the result? So let's dive into this amazing journey. And before, I want to add in point that my PC is not working, so I'm using my phone. So my video will be switched off. I'm sharing my screen. Okay, I hope my screen is visible to you.
Yes, Khushi, the screen
Yes?
is visible. Yeah.
Okay, thank you so much. Okay, just for a moment. Okay, before diving into the project, let me show you and give you a brief about what exactly citizen scientists. So, citizen science is a practice of public participation and collaboration in scientific research. Through citizen science projects, people share and contribute to data monitoring, collection programs. Actually, there are a lot of data from the telescopes as well as from the astronomers, but they don't have sufficient time. The scientists don't have literally sufficient time to monitor and dive into each and every data set. So they bring out some projects which are known as citizen science, because in these projects the amateur astronomers, people from the general public, those who are not in astronomy background, as well as students, the local people, the homemakers, anyone can participate from anywhere. They just need a good internet connection with a mobile phone or a laptop. Some projects they actually needed to be solved by using a laptop or a computer, but most of them, for example, Zooniverse is one of the most amazing program and the site where you can explore the projects. There are a lot. What you have to do, you have to search Universe on the Google and go to the first site, and the screen will show you, will appear like this. You just have to sign in. Just for a moment. Mm, I guess it's not working. What happened? Just a second. Okay, no problem. I'll tell you again. Okay, there are a lot of projects in each and every field. You have to go to search all the projects and you'll see there is not only from the not only from the space background, but there are a lot from arts, biology, climate, history, language, as well as up to space. In space, we have around 21 projects in which some are working, some have out of data. Okay, so let's move into one of the most amazing project, which is known as the Witch Hunters. Okay, so let me ask you one thing. Do you have any idea of what exactly a glitch is? Anyone who wants to answer? Can you guess what exactly it would be? About what? About what? A black hole, a neutron star, as the Teja mentioned, variable stars, or what? Okay, I guess nobody has an idea, so I'll tell you what exactly it is. So there are ripples in the fabric of the space-time, as we all know. And there are cosmic messengers probing the dark universe, and these are known as gravitational waves. So it predicted by more than a century ago by Albert Einstein, gravitational waves are bringing new information on the most violent events in the cosmos. For example, merging of a black hole or a neutron stars. So, through this project, you'll help the scientists to make gravitational wave detectors more sensitive and to listen to the new sources in the universe. So, there are literally a lot of projects, a lot of data sets available on this platform. What How to detect a gravitational wave? This is the question that arises in the mind of everyone who is looking at this project. So modern gravitational wave detectors are updated and much bigger version of the Michelson interferometer. So it is an instrument that allows precise measurements, exploring the interference of two beams of the light. So the advanced Virgo and LIGO use a source of laser light that is divided into two orthogonal paths by a semi-reflective mirror. Okay, I'm going so deep in that. So let's give you a short example. So as we all know that light consists of electromagnetic waves. So at the detection, the photodiode used in this used in this instrument, it interfere the pattern due to superposition of the waves, and they detect a gravitational wave. And the structure of the LIGO interferometry is literally so big that the data comes is so precise, and this is a basic principle of the gravitational wave detectors. Okay, and let's move into what exactly and how to do that. Okay, so this is the project, and it will definitely welcome you with a note of the information that how to use the data sets, how to explore it, and how to submit it. Okay, so first of all, the data will look like ripples as well as curly spikes. Curly spikes in a sense because they are literally looks like a ripples of the space time. It actually, in this is a glitch. When we talk about the gravitational waves, there is a glitch between the LIGO interferometry. So the glitch shapes in a very diverse manner. Some are low frequency bursts, some are scratchy, some are wily mode, and some are whistle. So we have a field guide which is available on the Zooniverse platform to help you and make you understand how to solve these data sets. So let's start it. And these are some kind of the glitches. You just have to identify and submit it, and that's so easy that you don't need any kind of uh, high microscope, sorry, high resonating telescope, as well as any kind of instrument. You just need your phone. Okay, so this is the graph and the picture given below, which is a data set. And in this options, you just have to identify what exactly it is. It is a blip? No, it's not. Is it extremely loud? The spikes are not sharp, so that's why it's not extremely loud. Is it a helix? It is not in a helical shape. It's not a helix. Is it a koi fish? No. It is a low frequency burst, scatter light, or what exactly it is. So how to know it? So we have a field guide provided. So in this, you have to look for it, and it will definitely show you how the burst look like, how to identify it. And when we got to know about this, we can identify it as a low burst frequency, and you can hear the sound as well. So we just have to click on low frequency burst and the next button, and that's it, it's done. And we have literally the next data set, and exactly in the same way you just have to classify it what it is. So this is an example of Zooniverse project, and there are a lot of more projects. So let's explore one more, and then we'll jump into another project. So let's see what's in our hands. When you go to space, we have a lot of programs available. Okay, one program is my favorite, and that's known as the Supernova Hunters. I hope the data is available or not. Okay, let's see. It's 100% complete. Oops. But I hope the data set will be available so soon. And one more thing I want to show you, that in Learn More, we have a a column of results. What exactly it result? That means the data you have solved, the contribution you have given to citizen science project has some significance. And what the significance is, when someone uses your data and the classification of yours, so it will help them in their projects, in their papers, and probably you will see that there are supernova hunters cosmic shovels discoveries. That means your name will be given in this discovery list if you have discovered what you see, it's a supernova. Okay, so let's get into it. When we go to the classify, and we have a task available, the field guide and the what you can see, it's a tutorial. Okay, so when we go to it, we will be, was second, one second, okay, I'll explain you. So this is the tutorial, how it looks like. This is the data set. There are three images from the same sky taken at different times. For example, the first one was taken a few years back, and the second one is the recent one. What is a supernova? Supernova is the burst in the space time. So in the space, when a star dies, it just bursts out, giving a lot of energy, and it looks like a burning star, which give off incredible, amazing light, which is which can be seen of more than 1,000 light years away as well. For example, we can detect supernovas from the Earth as well. The Betelgeuse in the Orion constellation is a supernova because it has exploded a few years, more than thousands of the years back, but we can see it in a few years because of the special theory of relativity given by Einstein. So the first image is taken a few years back, a few years back, and the second image is taken just recently. And when we use a filter, we can know the third image, is there any spot, a bulb, or you can say a yellow, a white or a yellowish light appearing in the center of the green mark. Okay, so when we go to it, the first one, it shows a green mark with a white dot inside it. In the second image, we can see there is nothing, and the third image, it shows that there is literally a white dot. That means it's a supernova, and we just have to say yes, and then it's done. In the similar way, there is the second image. We have a little white dot in the green mark, and in this next image we have the same one. In the third image we have the same one. That means there is no supernova. Supernova happens when a star bursts. That means there is an explosion in the space. So the images shows same image, the three image shows the same part of the sky, but there is no white light. So it's not a supernova, and then we have to click no, and then done. So this is how you have to classify. Okay, the third one is very this data set is literally amazing, because in the center we see there is no white dot. That means in the left one we can see there is a white dot in the green mark. That means there is a supernova burst. And in the last one, when we use a filter of both the two images, we will see a green mark with the white dot. It shows that it is a supernova. Then we have to click yes, and it's done. This is how you have to classify the projects, and to be honest, this is one of the amazing project according to me because I used to hunt a lot in this project. It's 100% complete, but I hope the data will be available soon. So this is the first program, which is known as the Zooniverse. There are a lot more. One of the Indian project named as Pune Knowledge Cluster is a community, is actually a group of people who started what you can see a citizen science project of classification of the galaxies. The one second, I'll show you. You have to go to Google and then search Pune Knowledge Cluster. Go to the first site, and here the magic comes. So what's the new? There is 1 million galaxies. It is a new citizen science project for astronomy and the program of the galaxies. So this is how it looks like, 1 million classification of the galaxies. Why we need people? Why we need citizen scientists? Because if we have AI, if we have statistical computers, so why we need? We need because to involve the people's contribution, to make people aware that there are amazing opportunities available in the field of the astronomies, the field and the space science community as well as the space industry is going at a faster rate. We launch a lot of rockets each year to various planets, to interstellar region, to Mars as well. But some of the people don't know the basic as well as the vast field of astronomy. So here comes Citizen Science Project to make people aware as well as to help the scientist in the data analysis. So what we have to do, the first thing that each and every site wants, each and every software wants, and literally anything is your registration or your login. So we will log in, and as I already did, just a second. Okay, I already logged in. I have to log in again. Okay, what exactly happened to me? I don't know. It was okay. Mm, okay, so the where the data comes from, the data of this particular citizen science project comes from the Subaru telescope that is in the Japan, and it is very famous. So Subaru Hyper Supreme Cam survey gives you the beautiful images of the galaxies, and you will have to classify. Know that you are pro in classifying the galaxies, so you will have to classify the galaxies as well as some are elliptical in nature or oval like structure. Okay, we have, for example, I'll give you the first image. This is an image of a galaxy which is provided by the Subaru telescope Japan. And what you have to do, it's very simple. You just have to classify the galaxies by literally seeing the given options below. Is it a tidal in galaxies? It has a tidal tail. Is it a shell, ring, bar, spiral, or it is an interacting galaxy? Interacting galaxy means the two galaxies merge at a center, or is it a group of galaxies and clusters? So what is it? So it looks like a smooth one. It has a bar or a ring inside it. It is spiral in nature. That's it. And we have to just submit it. Just a second. Yes. And now we have the next image. Okay, this shows that that the galaxy has a ring as well as it has spirals. It looks like there are a lot of galaxies or the clusters. So it is. Is it a smooth or not? No, because the spirals are very sharp in nature. And then we have to submit it. And this is how you have to classify the galaxies. And this is how it looks like. And along with it, you can check your data as well, how much galaxies you have completed, as well as your you can see your report card. In this Pune knowledge cluster, we have a lot of other projects. For example, the first project is the galaxy classification, and the next project is literally upcoming, which is about the variability in the quasars. As the Teja already mentioned, the variable stars are the stars whose brightness it changes by time. And similarly, there are some quasars as well whose luminosity varies with time. And the next project, it's upcoming. It will be just in 1 month or about 3 weeks. So we'll dive into it later. And the next project I want to show you is Galaxy Cruise. It is the American project. We have to just write it just a second. Uh, okay, so this is how it looks like. We just have to click on the first one, and here some magic begins. It's actually interesting. If someone is interested in games, especially the exploring ones, he or she can join it, because the structure and the, you know, making of this software, it just looks like a game. And I prefer to use this one in a desktop site if you are using your phone, because otherwise it will not show you the complete screen. And how to start it? We just have to get started, and then it will show you the concept, what exactly the galaxy cruise is. So it is a citizen science project in which ordinary people and scientists come together to explore the galaxies. And what are the features of the galaxy cruise, because this is a basic thing that we have to know about. So it will provide you the tutorials, the knowledge about the classification of the galaxies, how two or three galaxies looks like, how the galaxies features what are the features of the galaxies, how it is different from one another, and all those things. It's just a 2 or 3 minute session. It just depends on your sites, how much time you give on reading. And the second thing, you just have to join it, you just have to log in. And then the third one is to just classify. And it is a similar project just like the previous one, which is about the galaxy classification from the Pune knowledge cluster. uh, okay, I'll show you how it looks like. And as I told you, there are some lessons, that is 1, 2, 3. The first one is the introductory session. It will just give you the brief about the elliptical and the spiral galaxies. The second one is the intermediate. It will show you how the interacting galaxies looks like, because in this picture you can see the two galaxies, they are merging together. I'm sorry. In the third one, you have to classify 2 or 3 pictures for your practice, and then you just you'll receive a boarding pass from the galaxy cruise, because it looks like a ship in which you all are the participants. And then you just have to classify the galaxies in a similar way. And what we'll get in the end, you will, after classifying the galaxies according to the needs of this project, you will get a certificate, merchandise, as well as some trophies from the galaxy cruise project, depending on the how much time you have given, how much contribution you have given to this project. So these three sites, the Pune Knowledge Cluster, the second one is Universe, and the third one is Galaxy Cruise. These are the amazing space and astronomy related citizen science project sites. And once you will get into it, there is no way back. You just have to just classify, and more than 1,000 of discoveries will be published in journals. As the Teja mentioned, in the AAVSO there are also discoveries. In a similar way, there are discoveries in these platforms as well. And the third one I want you all to know about is the IASC, that is IASC, International Asteroid Search Campaign. This is the one of the famous one. When we talk about the citizen science project, the first thing that came into mind, okay, the project which involves the asteroid hunting. And yes, it is. So what it is? So the International Astronomical Search Campaign is the program which is the whole in which the whole world is participating. Anyone from anywhere, any background, they can join and they can participate. There is no previous astronomy knowledge required, as well as the tutorial will be given in each and every one. What you have to do is to just register, make a team of minimum 2 people, and you will get the days of the campaign in about 1 or 2 months, if you are registering through yourself, the individual participation. Otherwise, if you can collaborate, you can register under some groups or under some organization. For example, SA Citizen Science Project, that is Suvarnacharya Citizen Science Project group, is actually giving you the opportunity to get involved into this project with the help of our mentors, with the help of our teachers, with that means the people who are exactly, and they are literally involved in this project from a long time back. It's very simple. Okay, let me give you a brief about it. Okay, we just have to go to campaigns. After registering, after giving us giving the IASC our details, our participation details of our team, and then when we go to campaigns, we can see there are a lot of campaigns running through this time as well. Literally a lot. For example, when we see that the All Bangladesh Asteroid Search campaign and the number of the teams involved in it. Similarly, we have just a second. Okay, for example, we have hands-on university India. So this is the Indian, what you can say, this is the Indian project, sorry, group of the people who involve the teams from the India. So how we can participate? We have to just register and then make a team with the perfect team name with minimum of 2 people, and then our team name will looks like this. And actually I have a laptop, but it's not in right now in my hands, as well as a PC, but there is power cut in my home, so I can't tell you because this project is not available on phone. It requires a PC or a laptop with a good internet connection. It's very easy. What you'll get in the end, you'll get this kind of certificate. I'll show you this kind of the certificate of the participation. And one more thing I want to know about, there are two kind of the discoveries of the asteroids, because asteroids, they are not one or two, there are thousands of the asteroid moving around the earth and in the region between the Mars and the Jupiter, in the main asteroid belt. The asteroids which are near to Earth are known as the near Earth asteroids. They are known as NEO, near Earth objects, and the far away in between the Mars and the Jupiter in the main asteroid belt, they are different from it. Okay, so in asteroid search campaign, you will be provided image sets from the IESC's telescopes in the Tokyo in Japan. For example, Pan-STARRS telescope is very famous, and most of the data comes from the Pan-STARRS. And you have to classify, you have to identify. It's not classification, it's identification. It's the searching of an asteroid between the given data sets. It looks like a game. Okay, we will talk about this in a particular session of IESC when we will organize it, and there we will show you, give you the total details. uh, in the participation, you will get a certificate for showing you that international soil search campaign from which to which date. This is the campaign dates, and the next thing is your name, your team name, the group or the team name you have participated in, the team name, and then in recognition of valuable contributions to observation of the near Earth objects and main belt asteroids by participating in the analysis of the image from pan-stars, and the logo of universe of the NASA, as this project, this campaign is connected in collaboration with NASA. So you will be known as a citizen science. You can have discoveries as well. The asteroids are basically of the two kind of discoveries. The first one is provisional and the second one is preliminary discoveries. Within the project, you'll get to know about the preliminary discoveries of the asteroids you have searched. Luckily, if it is, because your data set, what you have analyzed, will go to the main office, to the main headquarters, and there the astronomers identify and doing their own calculations with the help of AI and other informations and systems. They will let you know if anything or you have discovered or not. The discoveries will be published each Friday in the campaign dates, and you'll know about these discoveries. This is the preliminary discoveries with the asteroids which are recently watched or seen by the telescopes. And the second one is the provisional discoveries, those asteroids taken in about 5 to 6 years of observation. If they come across the earth, they may be harmful or not. You have heard about the news that asteroid is coming towards the earth. It may hit or not according to the position and the other factors and the parameters which we use to determine for the collision between the asteroid and the earth. And if you have a provisional discovery, you will get another certificate with a particular mention of the provisional discovery of the main belt asteroid with the name, and you will get a chance to name it with your name, name the asteroid with your name in around 2 or 2.5 years. And this is how you get the certificate. You can show it to anyone anywhere with a tag that you are a citizen scientist who helped the science, who helped the scientists, who helped the astronomers in the data analysis. Because your little contribution can bring a lot of change in the societies, in the science community, in the involvement of the people in these projects, as well as in the future maybe you will be the one who discovered another black hole. And that's it from my side. This is how the citizen science projects look like. Let me close my screen. If you still have any doubts, please unmute yourself, ask, and get involved.
So I guess there was already a question in the chat asking, can we work on Pune Knowledge Cluster using mobile?
Yes,
That was
yes. You can go to the Pune Knowledge Clusters citizen science projects through your mobile phone, Android, your tablet, your PC, your laptop with anyone. But the IAC one is specifically from the PC or a laptop.
And there is another one. How can we differentiate variable stars from twinkling stars? Which is the common question I get all the time. So the thing is, twinkling is something when you see light of a star being bent, it's being refracted. But if it is a variable, you observe it through your telescope and click a picture of that today. And tomorrow you see the same star and you click a picture of that star, and you do it for a month or a year. You can see the star's brightness is not same. So twinkling stars are like you see the star's brightness same every day. The twinkling is same. But in variable stars, even there is a variability in the twinkling as well. So that is how you can differentiate between variable stars from twinkling stars, because when you observe it from your telescope you click a picture and the next day you do it, and the next day you do it, you see a change. So in the same way, maybe I would wait a minute. Still there, yeah. So as I showed you, there is a change. I don't want to go to the PPT again, but there is a change in the brightness of a star, uh, even though it's not twinkling. Because whenever you see a star, so let's take an example now. So you see Sirius, which is the brightest star in the night sky, and you see Betelgeuse, which is in the end stages of its main sequence life. So which is a variable because it's in the end stages of its main sequence life, or say algal, which is the eclipsing binary. So Betelgeuse and algal are variables, but whereas Sirius is not. So the twinkling of Sirius every day is same, but the twinkling of algal and Betelgeuse is not same every day, because say algal is an eclipsing binary, as I said earlier. There's nothing happening inside the star for the variability, but outside events are stopping the brightness of the primary star. So these kind of variables are called as extrinsic variables. So intrinsic variables are those kind of stars where something is happening inside the star itself. Say the Sulphide variables, the first standard candles. So because of the ionization of helium, the star, say there is helium plus, So when the star actually gets a lot of kinetic energy, which is much hot, and it expands, and when it expands, it gets an electron, and uh, it gets again to helium, and then again because of much heat, it expands and contracts, and it's like breathing in and breathing out. So that is how you can basically differentiate between a twinkling star and a star which is actually changing its brightness due to different reasons. And also there is a difference in the light curve. Not all the light curves are same. So say for the eclipsing binaries, the light curve is like very simple. But whereas for cataclysmic variables, there is a very in the PPT as I've showed you. So that is how you can actually differentiate between different variables, as well as whether it's a twinkling star or is it a variable star. In the observing section of the AAVSO database, that is very well clearly mentioned. So I would really like you to go there and check that out. I'm posting the link of the AAVSO's homepage in the chat. And the mail ID of AAVSO. And yeah, if there are any precise questions to me, you can use the last one. And if there are any other questions, we would want you to please unmute yourselves. And
Well, if anyone have any questions, please ask your questions right now, because maybe later you won't get a chance. So please ask your questions in the chat right now.
I guess there are no more questions. So we'll wrap up the meeting.
Well, I guess no one else have any other questions. So before ending the meeting, I would like to give a brief introduction about SS Citizen Science Group. So SS Citizen Science Group is basically a WhatsApp group in which encourage people to participate in various citizen science projects around the world. SS Citizen Science Lab is a new initiative of this group to create citizen science lab in schools and colleges. So teachers and students can participate in various citizen science projects and scope of work for with science teams. And if anyone else is interested in joining the SS Citizen Science group, I would like to say give more details about the SS Citizen Science group, and I'll be giving the details in the chat. So please feel free to visit their web, GitHub, and you can also email them, and I'll be giving the WhatsApp number. Well, Teja, someone have asked a question to you in the chat. Would you like to answer that? Teja, I think your mic is mute now, right now.
Okay, so I'm school student by day, and by night I'm an avid amateur astronomer. So like, how do I manage is kind of tricky. No one asked this question to me before, so I don't know what to say. But yeah, when you're interested in something, you yourself know how you can manage stuff. When you're interested in something, you will have a plan of how to manage uh, all the kind of stuff which is just put upon you. So it's like by evening I complete all my school stuff, and then in the evening I do variable star observation, report them to the AAVSO. We have few ambassador meetings and all that stuff. So managing is not a very big deal, but interest is. Once you are interested in managing, isn't something pressurizes you. So yeah. All right, so it seems there are no more questions. And with this, thank you everyone for joining. It's been a great time here, and hoping to see you again. And yeah, hope you all have clear skies.
I'll be providing the certificate form link in the chat, so please fill up that and you will get the certificate. And also, we are organizing a master class on orbital mechanics, which will be starting from 9th and it will be up till 11th of April. So the registration is still going on. It's till tomorrow 12 p.m. 12 a.m. So please feel free to join that masterclass. It's only 149 rupees to join for the registration. And I'll be providing the details of that masterclass too. Oh, sorry, the link of the masterclass. And at last, I would like to request everyone, please switch on your camera for one time so we can take pictures and for our memory purpose.
Thank you, everyone.
Okay, everyone, you may leave now.